Okay, in our final example, example 7b, I need to find the inverse of this and then show that algebraically they are inverses. So the first thing I need to do, replace my function notation with just the letter y. So I get y equals 2x plus 1 over x minus 1. If I'm trying to find the inverse, I need to switch the y to be an x and switch every x to be a y. So I get 2y plus 1 over y minus 1. Now I need to solve for y. Here's where it takes a little bit of work. So the first thing I'm going to do is multiply both sides by the denominator, the y minus 1. Because on the right side, my y minus 1's will cancel. On the left side, I need to go ahead and distribute here. So I get x times y is xy. X times negative 1 is negative x. On the right side, I still have 2y plus 1. If I'm trying to find y, I need to get the y's on the same side. So let's subtract this 2y, and let's add the x to the other side so that we get everything on the correct side. So I have got xy minus 2y equals, the x's cancel, the 2y's cancel, equals x plus 1. So all I've done is move the x to the right side and the 2y to the left side. On my left side, I've got xy minus 2y. Well, they both have a y, so let's factor that y out. I've got x minus 2 equals x plus 1. That looks much better, doesn't it? Divide both sides by x minus 2. The x minus 2's cancel, so I've got y equals x plus 1 over x minus 2. So I'm going to write that as my inverse function notation, equals x plus 1 over x minus 2. Now we just need to show that they are inverses. So to show that they're inverses, remember I've got to get f of f inverse of x and show that that equals x. So hopefully I have enough room right here. So f inverse was x plus 1 over x minus 2. So I'm going to input all of this now into my original function. Wherever there is an x, I'm going to be putting all of this. So it's going to be 2 times x plus 1 over x minus 2 plus 1 over x plus 1 over x minus 2 minus 1. Okay, doesn't look great, I agree. But let's go ahead and multiply that 2 on the top. So we've got 2x plus 2 over x minus 2 plus 1 over x plus 1 over x minus 2 minus 1. Now if I want to combine these two, I have to have the same denominator. So my denominator here is x minus 2. So I've got to multiply the 1 by x minus 2 over x minus 2. Because that's the same as multiplying by the number 1, which we can always do. And I need to do the same thing over here. Okay. So now, let's see what we have in the top. We still have the 2x plus 2. Now I'm going to multiply that positive 1 times x and the positive 1 times 2. So plus x minus 2. Okay, and all of this is over x minus 2. Now we need to do the same thing in the denominator. I still have an x plus 1. And now I'm multiplying the negative 1 times x and the negative 1 times negative 2, which gives me a positive 2. All of this is over x minus 2. Okay, let's simplify this. So in my top fraction, I've got 2x plus x. That gives me a 3x. Positive 2 minus 2, those cancel with each other. So all of that is over x minus 2. In my denominator fraction, x minus x, okay, those cancel. I've got 1 plus 2, so that gives me a 3 over x minus 2. So I've got a fraction divided by a fraction. And anytime we do that, we've got to take the reciprocal of the denominator. So this is going to become x minus 2 over 3. And notice here, I'm multiplying all these together. So if I've got the same things getting multiplied, the x minus 2's I can cancel. And I've got 3x over 3. The 3's cancel, giving me x. So I've now shown that f of f inverse of x equals x if this is the inverse. So we've proven the inverse of function f is this, x plus 1 over x minus 2.